Alright, so in this video we're going to be taking a look at one of the questions from this handout, which is a grade 12 physics handout and dealing with the topic of projectile motion. So I will read the question that we are going to be solving in this video. I will also include it in the episode description in case you want to read along. So, a cannon is aimed across a bottomless gorge, here's our bottomless gorge, at an angle of 22.6 degrees above the horizontal. The mouth of the cannon is 1.00 meters above the ground. So this cannon is elevated 1 meter above the top of the gorge. It shoots a ball whose velocity upon leaving the cannon is 130 meters per second. And there are three parts to this question. First, we have to determine the horizontal and vertical components of the initial velocity of the ball. Second, we are asked to find the velocity of the ball after 2 seconds. And finally, if the ball strikes the other side of the gorge at 54 meters below the rim, how wide is the bottomless gorge? So, I will solve these parts in order. Let's get right into it. Alright, so for part A, we are asked to find the horizontal and vertical components of the initial velocity. So to do this, we're just going to use our basic cos and sine functions on our calculator. So let me just extend that for a bit. We have a vector of 130. We'll forget about units for now. We'll just care about the number 130. So for this vector, and it also has an angle here of 22.6 degrees, it's going to have a horizontal component. We'll call that v of x. And it's also going to have a vertical component. We call that v of y, for y-axis and x-axis. Now the way you can find this is to find the y component, v of y. That is going to be 130 times the sine of 22.6 degrees. Now that's because the sine function is opposite over adjacent, so by multiplying 130 times the sine of this degree, that will give us the length of this line, the opposite line to this angle. So if I put that on my calculator, 130 sine 22.6, I get 49.9 blah blah. I'll round it to two digits at the decimal place, so that is 49.96. Now, when reporting this answer on a test, since this value is given to us with 2 significant digits, we would report that to 50, but I'm just going to keep track of an extra 2 significant digits just in case I need to use it for future calculations. Okay, similar idea with v of x. We're going to have 130, but this time times the cos of 22.6, and that will give us 120.02. And again, we would report this just as 120 meters per second, but I'm going to keep the extra 0.02 for future calculations. So these would be the components of the initial velocity. Okay, so now we got to do the second part of the question, which asks us to find the velocity of the projectile 2 seconds after it launched. So the key to projectile motion questions is that you have to think of the projectile acting independently along both the x and the y-axis. So in other words, you can think of it of having 2 different velocities and then combine them at the end when you want to find the overall velocity. So let's take a look at the x-axis. So along the x-axis, do we have any acceleration? No. There's no acceleration along the x-axis, which means we have a constant velocity. So it's already written there, but I'll rewrite it up here because the x-axis throughout the entire problem is going to be 120.02 meters per second because it has a constant velocity. Okay, it gets a little more tricky for the y-axis. So our initial velocity along the y-axis, as we know, is 49.96 meters per second. Our acceleration is negative 9.8 meters per second squared, and the change in time is 2 seconds. This is all we know. And what are we looking for? Well, we would be looking for the final velocity along the y-axis. So, we have 4 variables to work with. We know 3 of them, we're looking for 1 of them. we can use one of the kinematics equations, one of the equations of constant acceleration. We would have to use the one that doesn't use displacement because we don't have a displacement value right here. So the one I can think of is Vf at y squared equals Vi, or no, sorry. Vf equals Vi plus acceleration multiplied by the time. This is one of our equations of motion. So we can just sub in our values here. Vi along the y-axis is 49.96. For the purposes of this, I'm just not going to include units because it'll all work out in the end. To that, we're going to add our value for acceleration, which is negative 9.8 meters. No, sorry, I said I wasn't going to do units. Negative 9.8. And the value for time is 2 seconds. If I just plug that into my calculator, 49.96 plus negative 9.8 times 2 gives me 30.36. So now we have an x component of 120.02, and we have a y component of 30.36. And the question asks us to find this component. This is the result that we're looking for. So if we use the Pythagorean theorem, we can find the magnitude of our velocity by finding the square root of 120.02 squared plus 30.36 squared. I'll just plug it in right now. 120.02 squared plus 30.36 squared gives me 123.80. And then theta is going to be the inverse tan of the opposite over adjacent. So 30.36 over 120.02. And if I plug that one in my calculator, tan inverse of 30.36 over 120.02 gives me 14.2, let's say. So, there's a lot of messy writing here, but my final answer is that the velocity after 2 seconds, I'll write it 2 for 2 seconds, equals magnitude of that. I'm going to be rounding to 2 significant digits. So to 2 significant digits, this is all comes to 120. So it's 120 meters per second, and then that's 14 degrees above horizontal. And this is how you answer the second part of the question. All right, now for the third and final part of this question, we need to figure out how wide the bottomless gorge is. So we need to figure out this distance. So what do we know? I always like to write down my givens. The displacement along the y-axis is going to be 55. Now the reason it's 55 and not 54, because the question says it's 54, 54 below the lid of the gorge, is because remember, we started a meter above. So if we're going to land 54 below the rim, since we started 1 meter higher, our total displacement is going to be 55 rather than 54. Negative 55 rather than negative 54 meters. Okay, we still have the same initial velocity along the y-axis. We still have the same acceleration. Now we just need to solve for the time. So we have to pick the correct kinematic equation, which is going to be delta D equals VI delta T plus half of A delta T squared. This looks messy, but hopefully you've all seen this before. It's just one of our equations of motion, and we just got to solve for T. So I could make this negative 4.9 delta T squared, because half of A is negative 4.9. VI delta T, so that's plus 49.96 delta T, and we're going to subtract D, so subtracting a negative gives us plus 55, and this equals 0. Now, using the quadratic formula, I can say I can solve for T. So I'm just gonna plug this all in my calculator and not mess up the whiteboard anymore. So we got negative B, so negative 49.96 plus or minus the square root of 49.96 squared minus 4A, which is negative 4.9, C, which is 55, and all of that divided by 2 times negative 4.9. So I plugged it into my calculator. I got a negative value, so it can be plus or minus. I'm going to try subtracting the square root, and I get a positive value. So I know that T equals 11.20 seconds. When I did this in my calculator, I got two values, one negative and one positive, but time cannot be negative. So yes, technically this equation would have two solutions, but in physics, we just got to go with practical values that we can use, and of course we cannot use a negative value for time. So it takes 11.20 seconds for our ball to hit the other side of the gorge. Now, knowing that, we can figure out the displacement along the x-axis. So the general form of an equation for the distance would be the velocity times the time, okay? Because v equals d over t, so this is just another way of expressing that. So we want to find the displacement along the x-axis. Remember, our velocity along the x-axis is constant. It's 120.02, and we're going to multiply that by our delta t value, which we just found, which is 11.20. And we plugged it in my calculator, 120.02 times 11.2. We get 1,344.224. Now remember, originally we were given two significant digits to do this entire problem with, so when reporting our answer, we would have to say that it is equal to just 1,300, because that's two significant digits. So yeah, the length, the width of the bottomless pit was 1,300 meters.